क्या रेख जी, किस सोच में डूबे हुए हो?
सर सोच रहा हूँ कि इन टू डायमेंशन इफ टू लाइंस आर आइदर इंटरसेक्टिंग और पैरेलल, पर जब गगन में गगनयान उड़ता है यानी प्लेन उड़ता है तो हमेशा ऐसा तो नहीं कि पैरेलल लाइंस में उड़ता है, फिर भी आपस में टकराता नहीं। ये कैसे होता है, ये क्यों होता है, ये कैसे होता है, वही सोच रहा हूँ।
वेरी गुड बेटा, ऐसा ही एटीट्यूड रखना। बी ए थिंकिंग पर्सन, ना कि फॉर्मूला कमिट टू मेमोरी एंड भविट टू कॉपी, ऐसा एटीट्यूड ठीक नहीं। तो आज लेक्चर नंबर 11 में हम इस समस्या का हल करेंगे। तो जैसे कि हमें पता है इन टू डायमेंशन इफ टू लाइन्स आर देयर they are either intersecting or they are parallel, like this. Either they are parallel or they are intersecting, like this. Either they are intersecting or they are parallel. But जैसा कि रिक ने समस्या उठाया, देखिए 3 डायमेंशनल स्पेस में there exist some lines. Suppose this cube. Okay, if we consider one line here and another line in this side, like that, then they are like that. Take this line like that. Then they will never meet, although they are not parallel. Here they are not parallel. So according to the theory or according to the concept of two-dimensional geometry, they should meet as they are not parallel, but in that case these two lines will never meet. That is, there exist some lines in three-dimensional space. They are neither parallel not intersecting. They are called nothing but skew lines, a beautiful concept of three-dimensional geometry. So without wasting any time, let's go to the blackboard. Welcome friends. So we have introduced the term skew lines, the lines which are neither parallel nor intersecting. Now another thing we have to remember in that, if these two lines are skew lines, see, they are not coplanar, that is, they don't lie in the same plane, right? In two dimension all the lines are lying on the same plane, but here the skew lines in three dimensional space, they need not be lie on the same plane. Okay, so this is one another important concept. Now we are going to find the shortest distance between two skew lines. Now what is the shortest distance? If in a two-dimensional plane, if these are two parallel lines, then the shortest distance between them is nothing but the perpendicular distance between them. This perpendicular distance is the shortest distance between these two lines. If two lines in two-dimensional plane are intersecting, then the shortest distance between them is 0. We have learned this in class 11 straight line chapter, right? So now in case of skew lines, how to derive the shortest distance between them? Here we will introduce another term, the shortest distance vector. Shortest distance vector between these two skew lines. Say these are two skew lines. Here line 1, this is line 2, these two skew lines. What we understand by the shortest distance vector? Shortest distance vector means one line segment joining these two, one point on this line and another point on this line, and the line segment must be perpendicular to both the lines. That is the shortest distance vector, and its magnitude must be the smallest. So how to derive this shortest distance vector between these two skew lines? We will learn in today's lecture, a beautiful concept we are going to learn today. So before dive deep into the ocean of three-dimensional geometry, I would like to discuss an important concept of vector algebra, which is known as projection of a vector on a line. So in the next slide we will see how to derive the projection of a vector on a line, because this concept will be used to derive the shortest distance between these two skew lines. Okay, so go to the next slide. So here, projection of a vector on a line. First we draw some vectors. First we draw the diagram. Okay, say this is line L. Another vector, say this one is a vector, say AB vector or A vector. Let this AB vector makes an angle theta with this line A. Now what do we mean by the projection? Projection is nothing but the shadow of the vector on this line L. How to derive this? See here, the vector A vector or AB vector makes an angle theta with line L. Draw one perpendicular from B to the line L. Say this portion is AP and this is say P vector. Okay, now projection of AB vector on line L is AB vector magnitude cos theta. This is nothing but AB vector dot a unit vector along the line L. So how to derive the projection of a vector on a line L? So just simply take the dot product or scalar product of the vector with another vector which is the unit vector in the direction of the line L. So very simple. We will see in real life example what is the projection. So switch off the lights. Sunny. So here we are. How to find the projection? Say this is the vector AB vector, and here below we are taking the projection. That is, I have told you projection is nothing but the shadow. So here I have taken the torch, projecting the light on this pen. The shadow, length of the shadow is nothing but the projection of this vector AB vector. If it is parallel to the line L, then the projection is nothing but equal to the length of this pen. If it is perpendicular, then projection is 0. Okay, you just use the formula, you can get it, because when this pen is perpendicular, then theta is 90 degree, just cos 90 is 0, and when this line is parallel to the line AB vector, this is AB vector, is parallel to line L, then theta is 0, cos 0 is 1. So in that case, projection of AB vector is equal to AB. So now we are going to use this nice concept to derive the shortest distance between two skew lines. Here these are two skew lines, right? And how to derive the shortest distance between them? See here on this line 1 and line 2, we will take 2 points, say A, S and T. This I will join by this thermocol, we just take the projection of this line ST on the shortest distance vector. That is and the magnitude of this shortest distance vector is nothing but the smallest distance between the two skew lines, which is the distance between the skew lines. Are you getting? If you have still doubt in this concept, you just listen the video a few more times and all your doubts will be gone. So now, Sunny, switch on the lights. So here we have to, if we have to find the projection of a vector on another line, so we just simply take the dot product of this vector with a vector that is unit vector along the line. We will use this concept to derive the distance between two skew lines. So here first we draw the diagrams. In that case, this is line 1C, this is line 2, okay. Say this is line L1, say this is line L2, say this point is S, say this point is T. This position vector is a vector, A1 vector, and this position vector is A2 vector. So proof begins. Proof. Let the equation of two skew lines R vector equal to A1 vector plus lambda times B1 vector, equation 1, and R vector equal to A2 vector plus mu times B2 vector, equation 2. Now let S be here skew lines L1, L2, R. Now let S be a point on line L1 whose position vector is A1 vector. And T be a point on line L2 whose position vector is A2 vector. Therefore, ST vector is A2 vector minus A1 vector. We use law of vector addition, triangular law, triangle law of vector addition. So previous page, see, if we take, as we have seen in the diagram, this is model, it's not diagram. These are the two skew lines L1 and L2. Here I have taken one point S, here I have taken one point T. So this is ST. And this is if this is the shortest distance between two skew lines, that is, if it is, name this as PQ. PQ. This is the point P and this is the point Q. If we consider this as the shortest distance between two skew lines, then this is nothing but the projection of this line ST vector on the shortest distance vector. Okay, so how to find the projection of a vector on another line? So that is why we have learned the concept of the vector projection. Here we just simply derive one unit vector along this line of shortest distance, and we just take the dot product of this line vector st vector with the unit vector along this line of shortest distance, and we are done. Okay. Let PQ vector be the shortest distance. Let PQ vector be the shortest distance vector between two skew lines L1 and L2. Therefore, PQ vector must be perpendicular to both B1 vector and B2 vector. Again, we have to understand this question, this statement. Why this PQ vector is perpendicular to B1 vector and B2 vector? So from the equation of the line 1 and from the equation of the line 2, these are nothing but the equation of a line passing through a given point and parallel to a given vector. So this line L1 is parallel to B1 vector, and this line L2 is parallel to B2 vector. Now we have learned that the shortest distance vector between two skew lines must be perpendicular to the lines. So this PQ vector is perpendicular to L1 and PQ vector is perpendicular to L2 respectively. But L1 is here L2, this is L2 means this is B2, and this is L1 means, sorry for that, I have to change little bit in the diagram the names. L1 means here, or just simply take this, change this name. This one is L2, this one is B2 vector, this one is L2, and this line is L1. P, and this one is B1 vector. Little bit change in the diagram, the names. B1 vector. So PQ vector being the shortest distance vector between the skew lines, so it must be perpendicular to line L1 and line L2. But line L1 is parallel to B1 and line L2 is parallel to B2. So PQ vector, the shortest distance vector, must be perpendicular to both B1 vector and B2 vector respectively. So we will use this to derive the unit vector along the line of shortest distance, right? We will go to the next slide. So PQ vector must be perpendicular to both B1 vector and B2 vector. So therefore, unit vector in the direction of line of shortest distance, PQ vector is b1 vector cross b2 vector by b1 vector cross b2 vector magnitude. So this is the unit vector say equal to n cap say. Okay, so we will use this later in this proof. Now let d be the magnitude of shortest distance vector. Distance vector, that is PQ vector. Therefore, PQ vector equal to nothing but what? dn cap, that is magnitude and direction. Altogether means makes it a vector. So now again let theta be the, see the image diagram, previous page. Here we are considering the angle theta between ST vector and PQ vector. Why we are considering? Again we have to find, our main objective is to find the projection of ST vector on PQ vector, right? So to get the projection we have to find the angle between the vector ST vector and PQ vector. That is, you can say we have to find the angle theta between ST vector and the unit vector along PQ vector. You just go through the concept of projection of vector, then you can get it very easily. So let theta be the angle between ST vector and n cap, where n cap is nothing but a unit vector in the direction of the shortest distance vector, that is PQ vector. Therefore, ST vector dot n cap equal to ST vector magnitude n cap magnitude cos theta equal to n cap is unit vector, so magnitude of a unit vector is 1, so ST vector magnitude cos theta. So therefore cos theta equal to what? ST vector dot n cap by ST vector magnitude. ST vector magnitude. Here we have just used the property of definition of scalar product of two vectors. So now we see the diagram again. Now we have in our hand a unit vector n cap along the shortest distance vector, that is PQ vector. Also we have the angle between ST vector and PQ vector. Therefore, to find the projection of ST vector on PQ vector, we are going to apply the formula. So the projection of ST vector on line of shortest distance, in short I just write it down SD, shortest distance, line of shortest distance PQ vector, is ST vector dot n cap, the unit vector along the line of shortest distance, equal to ST vector magnitude cos theta. What is the value of cos theta? See previous page. st vector dot n cap by st vector magnitude. St vector dot n cap by st vector magnitude, value of cos theta, and this st vector will remain in its place. So st vector dot, what is the value of n cap? b1 vector cross b2 vector by b1 vector cross b2 vector magnitude. Equal to, what is st vector? We have derived here. St vector is, take this reading, a2 vector minus a1 vector. So we just simply put a2 vector minus a1 vector dot b1 vector cross b2 vector by b1 vector cross b2 vector magnitude. Take the magnitude of whole thing, because it is a distance, so we have to take the positive sign always. So this is the form, this is the formula, you can say, that is a2 vector minus a1 vector dot b1 vector cross b2 vector by b1 vector cross b2 vector magnitude. This is the vector form formula of the shortest distance between two skew lines. Name it as relation 3. So therefore, in the next page, therefore the required shortest distance between the skew lines r vector equal to a1 vector plus lambda times b1 vector and r vector equal to a2 vector plus lambda mu times b2 vector, while lambda and mu are what? Non-zero real number, non-zero scalar, is a2 vector minus a1 vector dot b1 vector cross b2 vector by b1 vector cross b2 vector magnitude. Take the magnitude of whole thing. So we have come to the end of today's video. We have derived the shortest distance between two skew lines in vector form. But solve the problems in the examination very easily. We have to learn the Cartesian form also. So how to derive the Cartesian from this? Here you can see this a2 vector minus a1 vector dot b1 vector cross b2 vector. This you just observe this term. Here b1 cross b2 vector is a vector quantity, but when we take the scalar product with a2 vector minus a1 vector, this becomes a scalar quantity. So this is nothing but the scalar triple product or box product, you can say. So now Cartesian form. Cartesian form. Let the direction ratios of line 1 and 2 are A1, B1, C1 and A2, B2, C2, and let a1 vector equal to x1, y1, z1, that is the coordinate of the point S, and b vector, sorry, a2 vector equal to x2, y2, z2, that is the coordinate of t. So therefore, here in the first page, we have taken the lines 1 and 2 are vector equal to this, vector equal to this in vector form. When a1 vector and a2 vector are given as x1, y1, z1 and a2 vector as x2, y2, z2, and when the direction ratios of b1 vector and b2 vector are given as a1, b1, c1 and a2, b2, c2 respectively, then we can simply write down the Cartesian form of these lines as, go to the next slide, x minus x1 by a1 equal to y minus y1 by b1 equal to z minus z1 by c1, and the line 2 becomes x minus x2 by a2, y minus y2 by b2 and z minus z2 by c2. Now we just simply use these line equations of these lines and put the values of a2 vector minus a1 vector dot b1 cross b2 vector and this, and we will simply get the Cartesian form of distance between two skew lines. So we know that b1 cross b2 vector can be written as I, j, k, a1, b1, c1, a2, b2, c2, right? So therefore the shortest distance between the lines 1 and 2 is, see here, if we take dot product a2 vector minus a1 vector with this b1 cross b2 vector, then what will I get? Ijk will be replaced by these components of this vector a2 vector minus a1 vector. So this thing again can be derived using the concepts of scalar triple product or vector triple product. You can learn it from the NCERT class 12 part 2 book. It is maybe in the appendix section. If you still have doubt with the scalar triple product or box product, put your comment in the comment section below. I will make a separate video for you just for the scalar triple product or box product. Okay, here if we take the scalar product of this with b1 vector cross b2 vector, this ijk will be replaced by the components of a2 vector minus n vector. So simply we can write this as x2 minus x1, y2 minus y1, z2 minus z1 by a1, b1, c1, a2, b2, c2. This is nothing but the term written here, that is the a2 vector minus n vector dot b1 vector cross b2 vector by another term is there b1 vector cross b2 vector magnitude. So this thing whole divided by b1 vector, not here vector, undo, just take his like that I, j, k cap, a1, b1, c1, a2, b2, c2. Take the whole magnitude. This is relation 4. So relation 4 is nothing but the distance between the two skew lines, what we have considered as line 1 and line 2 here in this diagram, and this relation 4 is in Cartesian form. So in exam, if in the questions you have to check whether the data of the lines are given in vector form or Cartesian form, and then you have to use the relation 3 and 4 accordingly and wisely according to the situation. Okay, so now we will see some application of the theory what we have learned in today's lecture. So here, find the shortest distance between the lines L1 and L2 whose vector equations are r vector equal to this and r vector equal to this. Say this is line L1, say this is line L2. So here the equations are given in which form? Vector form. So we will use the formula in vector form. So comparing the equations of line L1 and L2 with r vector equal to a1 vector plus lambda times b1 vector and r vector equal to a2 vector plus mu times b2 vector, we get a1 vector equal to I plus j cap and a2 vector equal to 2I cap plus j cap minus k cap. Therefore, a2 vector minus a1 vector equal to what? 2I minus I means I, j minus j will vanish and minus k cap. So I minus k cap. A2 vector minus a1 vector. And here also here b1 vector equal to what? In the next page we will write b1 vector. Here b1 vector equal to 2I cap minus j cap plus k cap, and b2 vector equal to what? 3I cap minus 5j cap plus 2k. So to use the formula, we have to first find b1 vector cross b2 vector equal to ijk, and components of b1 vector means 2 minus 1 1, here 3 minus 5 2. So minus 2 plus 5 4 minus 3 minus 10 plus 3 3I cap minus j cap minus 7 k cap. Also we need to find b1 vector cross b2 vector, its magnitude. So square root 3 square minus 1 square minus 7 square equal to 9 plus 1 is 49. So means 59. Okay, now we will put the value. So therefore the required shortest distance between skew lines L1 and L2 equal to, we just simply put the formula, right? A2 vector minus A1 vector dot
b1 vector cross b2 vector by b1 vector cross b2 vector magnitude. So here simply previous page a2 vector minus a1 vector means I minus k cap, I cap minus k cap, I cap minus k cap dot b1 vector cross b2 vector means 3 I cap minus j cap, 3 I cap minus j cap minus 7k cap by magnitude of b1 vector cross b2 vector. Previous page we have derived this root over 59. Whole thing we have to take magnitude. Now this one scalar product. This value will be 3 minus here minus plus 7 by root 59 magnitude. So equal to 10 by root over 59 unit. So we are done. So next we will see another application of this formula. Here see the equations of the lines are given in Cartesian form. So we are going to use the relation 4 that we have derived in lecture number 11. So here say this is line L1 and say this is line L2. So therefore solution. Comparing lines L1 and L2 with x minus x1 by a1, y minus y1 by b1, z minus z1 by c1 and x minus x2 by a2, y minus y2 by b2 and z minus z2 by c2. We have x1, y1, z1 equal to what? Minus 1, minus 1, minus 1. From this L1 we just compare these two, x minus x1 by a1, y minus y1 by b1, z minus z1 by c1. So minus 1, minus 1, minus 1. And x2, y2, z2 means comparing this with line 2. Here it is 3, 5, 7. And what are the a1, b1, c1? Values of a1, b1, c1 are 7, here we have to erase this. A1, B1, C1 are what? A1, B1, C1 are direction ratios. So we will denote it like that. 7 minus 6 minus 6, 1. And A2, B2, C2 means what? 1 minus 2, 1. So we'll just use the formula, that is relation number 4, to derive the distance between the skew lines. So therefore required distance, shortest distance, required shortest distance is, what is the formula? x2 minus x1, y2 minus y1, z2 minus z1 by a1, b1, c1, a2, b2, c2 by here nothing but b1 vector cross b2 vector magnitude, take whole magnitude. So equal to see previous page. What are the formula we have written? Relation 4. B1 cross B2 vector means ijk, A1, B1, C1, A2, B2, C2. Right? So just simply B1 cross B2 vector magnitude. Next. Yeah. So here x2 minus x1 means, see the previous page.
x2 minus x1 means 3 minus or minus 1 means plus 4. 5 y2 minus y1, 5 minus or minus 1 plus 1, 6. 7 minus or minus 1 plus 1 means 8. So 4, 6, 8. 4, 6, 8. Have you understood this step? Put in your comment in the comment section below. And here a1, b1, c1, 7 minus 6, 1. 7 minus 6, 1. And a2, b2, c2. a2, b2, c2 means 1 minus 2, 1. 1 minus 2, 1. And what is b1 cross b2 vector magnitude? Simply I, j, k, 7 minus 6, 1, 1 minus 2, 1, take whole magnitude equal to, here we will solve the determinant, 4 minus 6 minus 2 is plus 4, minus 6 plus 2, minus 6 into 7 minus 1 plus 8 into minus 14 plus 6, take magnitude. Below I cap, same thing, minus 6 plus 2 minus j cap, 7 minus 1 plus k cap, minus 14 plus 6, take whole magnitude equal to, here minus 6 plus 2 minus 4 minus 16, 7 minus 1 6 minus 36, minus 14 plus 6 minus 8 minus 64, take the whole magnitude by minus 6 plus 2 minus 4 I cap, 7 minus 1 means minus 6 j cap, minus 14 plus 6 minus 8 k cap. So we will write it, this expression again in the next page, minus 16. So what we have got, minus 16 minus 36 minus 64 magnitude, and here below minus 4 I cap, minus 6 j cap, minus 4 I cap, minus 6 j cap, and minus 8 k cap. We are just going to finish the problem. So here 64, 6, 70, 80 and 36. So 116. As we have taken the magnitude, so we will take the positive sign. And here the magnitude is 16 plus 36 plus 64. Same thing, 16, 36, 64. So 116 by root 116 equal to root 116. Can we simplify this? 2 5s 8, 2, 2, 4, 90. So here 2 root over 29 unit. So answer. So we have solved two applications of the theory. What we have learned, we have used the relation 3 and 4 accordingly and wisely. Where vector forms are given in the equation, in the question, then you have to use the relation 3. When in the question Cartesian form is given, then you have to use the relation 4. So thank you for watching. Hope you have enjoyed this today's video a lot.